is electromagnetic in nature. Now, what is electromagnetic wave? If anyone can tell me. What do you understand by
Electromagnetic wave is a wave that does not need medium to travel.
Very good. So electromagnetic wave is a wave which doesn't need medium to travel. So it can even travel in vacuum. And light, of course, propagate in the form of transverse wave, right? So we can say that light is that part of electromagnetic spectrum which, because of which we are able to see the things around us, right? So write down what is light. Light is that part of electromagnetic spectrum which enables us to see. Light is that part of electromagnetic spectrum that enables us to see. Okay, and it is transverse wave. Okay, and then when light strikes a surface, there are various phenomena which can happen, like reflection, refraction, absorption, etc. So depending upon the nature of the surface, any one phenomena or more than one phenomena can happen at a time. Like for example, if you see, like say if you see a water, a lake surface, and there is a fish. Okay, then if you see from the top, you'll be able to see the fish as well as you'll be able to see your own reflection on the water surface. When you are able to see your own face on the water surface or reflection on the water surface, that is actually happening because of the reflection of light. The light which is incident, it is getting reflected back, because of which you are able to see it. And also there is a refraction. Light from the fish, coming from the fish, is also coming back to your eyes, and hence you are able to see it. So that means light is traveling from one medium to another medium, and this phenomenal reflection, bending of light when it moves from one medium to another medium, is called reflection. Also, light is getting reflected back from the upper surface of water. So both the phenomena are happening. So actually, whenever light falls on a surface, reflection, refraction, and absorption of light can happen. Okay? So write down that when light falls on a surface, okay, reflection, refraction, and absorption of light can take place. Okay? It can happen depending upon, it depends upon the nature of the surface. It depends on nature of the surface. That is which phenomena will be prominent. Will happen. Okay? Like if it is an opaque surface, of course transmission of light won't happen. There will be no refraction. So reflection and some part of energy will be absorbed. The absorption and reflection of the light will happen. Okay? If it is a transparent surface, then refraction will be the prominent phenomenon. If say depending upon how which type of sometimes you offer up some films on this glass surface which is very smooth on the outer surface. So when the light falls on it, it gets reflected back. So you're able to see your own reflection on the surface. It acts as a mirror, and also the light can transmit to the glass, and you can see from inside. You can see the outside, things out of the room. So that means again, depending upon the nature of the surface, reflection, refraction, and absorption will happen. Okay? Then if we see that how these are few general things about light, and then we'll start with the reflection. Then do you know this thing that why we are able to see the things around us, or how we are able to see the things around us? How light helps to see the things, us to see the things around us? Yes. If you know, please raise your hand. Please explain. Yes, Ritesh.
When light falls on the object, it reflects back on that object and comes to our eye. And in our eye, it is converged by a convex lens which is present inside the eye on the retina, from which a signal is passed to the brain through the optic nerve, which allows us to see.
Oh, right. So that means we are able to see the things around us because when the light from a source falls on that surface reflects the light, and this reflected light, the light which is reflected from a given surface, when it reaches our eye, we are able to see that object. Okay, so that's why when there is no light at all, it's completely dark, then we won't be able to see the things. And why we perceive a particular color or a particular from the object, how the color we are able to sense, it is again because what exactly happens is that when light falls on a surface, every surface has this tendency that it absorbs some wavelengths and reflects back some other. So the rays or the wavelengths which are being reflected back, okay, when they reaches our eye, the object appears to be of that color. It means, say, there's an object which appears to be red in color. So that means when white light falls on that surface, all the wavelengths except red, or all the colors except red color, is being absorbed by that object, and it is reflecting back only red color. So the color which is being reflected back from the surface when it reaches our eye, so it appears to be red in color. So is it clear that why an object appears to be of a particular color? It is because when the white light falls on the surface, the body absorbs certain colors and reflect back the remaining. So the colors which are being reflected back when it reaches our eye, we are able to or we perceive that object to be of that particular color. I think so. This concept is clear to everyone. Okay. Then we know that light travels with a speed of 3 into 10 raised to power 3 meter per second in vacuum. Okay. Very good. Yes,
3 to 10 to the power 8.
Sorry, really, sorry, beta. It's 8 only. 3 into 10 power 8 meter per second in vacuum, and this is the fastest speed. Okay. And all the wavelengths of light travels with the same speed. However, when the light enters in a particular medium, okay, the speed of light changes depending upon the nature of the medium, and we represent it or we measure it in the basis of refractive index of the medium. We'll discuss this point in the when we discuss the topic refraction of light. Okay. So in vacuum, all the wavelengths travel with the same speed, and speed, and this is the maximum speed, right? So these are some few general points regarding light, and now we'll discuss the reflection of light. Write down reflection of light. what is reflection of light? As people have told us initially only that it is a bouncing back of light ray when it falls on the surface of an object. Okay, so the bouncing back of light ray when it falls on the surface of an object, right? Okay. So whenever this happens, light follows certain rules and we represent it by laws of reflection. So say this is a light which is incident on the surface, and the point where it is incident on the surface is called point of incidence. If we draw a perpendicular on the point of incidence on the surface, the angle which incident ray makes with the, this perpendicular is referred to as normal and stands for normal. Okay, to the surface. So the angle which incident ray makes with the normal is referred to as angle of incidence. I is angle of incidence. So this ray will get reflected back, bounce back into the same medium. Okay. So this is a reflected ray. Reflected ray makes an angle R with the normal, which is referred to as angle of reflection. Okay. Okay. The laws of reflections are number one, that angle of incidence is always equal to angle of reflection. Okay. Whenever reflection happens, angle R is equal to angle R. And second is that incident ray, reflected ray, and normal on the surface are always in same plane. Okay. Incident ray, reflected ray, and normal are in same plane. Okay. These are the laws of reflection which are always followed whenever reflection happens. So, in nature, there are two types of reflection which we observe. One is called regular. Okay. Regular reflection. Regular reflection is also referred to as specular. And the second is called diffused or irregular reflection. Okay. Difference is that regular reflection happens on the smooth surface and diffused or irregular reflection happens on a rough surface. So, say this is a perfectly smooth surface. When a beam of light, what do you understand by beam of light? It is a broad
Direction of
light.
light
Yeah.
in the same direction.
Yes. So when this beam of light is an incident on the surface, at every point of incidence, let's draw a normal. So following the laws of reflection, since rays are parallel to each other and normal are also parallel to each other, therefore angle of incidence will be equal in each case, and hence angle of reflection will also be same. That means all the reflected rays will be parallel to each other. So that means for incident beam, we'll obtain reflected beam. And this type of reflection is called regular or specular reflection. And of course, this type of reflection you will observe whenever the surface is smooth. So if you incident a beam of light on mirror surface, then you'll see that the path of the reflected beam will also be it will make a certain angle and go in that direction. Okay? If it is a narrow beam of light, it is not a diverging beam of light. As it should be like if you incident a laser beam on a mirror surface, then you'll see that it will get reflected back in a particular direction. Okay? It will not spread out. So there the reflection is regular reflection or specular reflection. Now what is diffuse reflection then? Say if the surface is rough and say a beam of light is incident on this surface. So at the point of incidence, if you draw normal, then you can see here that normal in each case will be different. This is N1, this is surface, normal and this surface will be N2 here, N3, and hence angle of incidence in each case will also be different. I2, I3. By following laws of reflection, at whatever angle the ray is incident, it will get reflected back and making the same angle. So that means for incident beam, the rays are getting reflected in all the directions. And this type of reflection is called as diffuse or irregular reflection. So it happens on rough surface. Now, even if when the reflection is happening on the diffused or rough surface, diffused reflection is happening, or I can say that reflection is happening on rough surface, you can see at each point of for every ray where reflection is happening, it is following laws of reflection. So laws of reflection are always followed or varied whenever reflection is happening. So for incident beam, we are getting rays in all the possible directions because at the point of incidence, the normal is different. Since normals are not parallel to each other, therefore rays are getting reflected at different angles. In general, the things around us are not perfectly smooth. So when the light falls on the surface, it gets reflected in all the possible directions from that surface, and that is the reason we are able to see the things around us. See, I'm in a room. An object is kept, say Elmira is in one corner of the room. I can see that Elmira from each and every point in that room. Why so? because of the diffuse reflection. When light is incident on the mirror surface, though it appears to be smooth, but its surface is not perfectly smooth, it has roughness. So when light falls on the surface, it gets reflected back in all the possible directions. So that's why wherever you are standing in the room, you are receiving the reflected light from the mirror surface, and hence you are able to see that in mirror, whichever corner of the room you are observing it. So generally, around us, the reflection which is happening is diffused in nature, and that is the reason we are able to see the things around us.